Will it be easier to hear me maybe on the video if we close that door? Yeah. And sine of A minus B is sine cos minus cosine. See how similar those two rules are? So what happens if I add them? Now I have a rule for a product of sine and cos. And that's the first rule on the sheet. No, it's not. It's the third rule on the sheet. Likewise, you can pick different pairs of those first four identities, add or subtract them, and you'll get the rest of the identities on there. Do you want me to show you each one, or do you think you can work that out? Do you think you can do it? See if you can work out what combination will produce the other three rules on the formula sheet. So I've just done this one. So think, how am I going to get 2 sine A sine B out of this? Oh, if I subtract these two, I'll end up with 2 sine A sine B. Shall we try it? Okay, third and fourth rules. Subtract, because I want to go sine A sine B minus negative sine A sine B. So I'm going to get number 4 minus number 3. Number 4 says cos A minus B is cos B plus sine A sine B. And rule number 3 says cos of the sum is cos minus sine. If I subtract, I'm going to get cos A minus B minus cos A plus B equals, that goes away, this minus negative, 2 sine A sine B. Which means sine A sine B is a half cos A minus B minus cos A plus B. That's the first rule.
Why would you want to substitute the products for that?
Let me ask you a related question. Why would I want to factorise? Why would I want to expand? Because it gives me more options. Sometimes this is easy to work with, sometimes this is easier to work with. Similarly, sometimes I'll have an expression like this, product, and I'll want it instead to be a sum. Sometimes I'll have a trig of a sum or difference and I really want individual angles. And sometimes the very next drop point in the syllabus, sometimes I'm going to have a linear combination of cos and sine. And for example, when I plot it, I want to have a single trig function because that's much easier to work with. So these are a whole lot of tricks, techniques, skills that you can then go on and use to do various things. Without them, you go, this is a mess, I don't want to do this. But, oh, wait a minute, I can simplify this, and this turned out to be easier. So like when you started doing this in grade 7 probably, into grade 8 and grade 9, and to begin with it was just algebra for the sake of algebra, but by the time you get to grade 9 and 10, you're using factorising and expanding to do much more complicated stuff. It's exactly the same. We're going to teach you the skills, then we're going to apply them. And we're going to use a lot of this for modelling and for calculus. Do you think you could use this kind of thing to prove that any of those 4 ones?
Mm-hmm.